Hello and welcome to the iSystem webinar series. Today's episode is about analysis of program execution and bus activities with iSystem tools. You will learn about recording and analyzing CAN, CANFD or LIN messages during the network activity of an embedded system. My name is Sabrina Kisslinger. I'm the moderator. Today's speaker is Aleš Kozir, who will lead you through the technical presentation. Aleš is Field Application Engineer at iSystem. His previous work experience in the automotive industry as an embedded software developer and tester makes him best understand the issues of software development and user applications. Before we start, I would like to give you some general information. During the webinar, you will be muted. If you have questions, please use the question tab in the menu bar. Below the question tab, the handout tab allows you to download the presentation. Today's episode will be recorded and published on the iSystem YouTube channel. At the end of the webinar, some of your questions will be picked and answered by Aleš. All others will be answered by email afterwards. So that's it from my side. Let's start. Over to you, Aleš.
Welcome from my side. After the webinar, you will be able to track CAN and LIN bus activities, inject CAN, CANFD messages, measure CAN propagation delays, automate the profiling measurement and analysis. First, we will overview the hardware setup. Then, we will look into the CAN-LIN module capabilities. Next topic will be how to profile CAN-LIN networks with the iSystem tools. Lastly, the automation will be presented. So, let's start. iSystem tools are built around the IC5700 BlueBox debugger. The specialty is extendability of the debugger with several add-on modules. First, on the top left is the ADIO module. ADIO module is used for analyzing analog and digital I/O signals and driving the output with the signals. Next on the picture is CAN-LIN module, used for network analyzing. You can analyze CAN-LIN buses. ActuProbe is special debug and trace connector for high bandwidth tracing and profiling of controllers such as Infineon RX and ARM Cortex via HSSTP, and so on. If more than one add-on module should be connected, the FNet hub expands the FNet ports from 1 to 4 pieces. At the back of the FNet hub is a special Ethernet port used for enabling synchronous debug and trace with the two iSystem debuggers on two CPUs on different ECU targets. The external devices are connected to the IC5700 over the FNet connections. FNet is an iSystem proprietary bus system and communication protocol that provides fast communication between devices connected to the same network. It enables fast communication between MCU and BlueBox, network analysis, synchronous debug and trace of multiple MCUs. On the left is a screenshot of the winIDEA IDE. It has some advanced features to speed up debugging. The real power of winIDEA can be found in its analyzer, a program and data trace visualization tool of trace, code coverage, and profiling measurement. It also supports real-time operating system awareness. iSystem can offer some advanced tools for timing analysis to cover arbitrary timing scenarios like AutoSAR event chains. Trace Analyzer can trace and profile signal on the IOs, SPI, and CAN-LIN messages with the use of add-on modules. A CAN-LIN module is attached to the IC5700 debugger with the FNet cable. With the IC5700 and a CAN-LIN module, you can track CAN-LIN bus activity. You can correlate a bus data to application behavior, measure worst-case timing analysis, for instance, end-to-end response time of a send and receive message. The isystem tool can generate triggers on network message, and this trigger can be used for start-stop events for the other equipment. For instance, with the ADIO module, you can generate digital signals used by the other measurement and test equipment. With CAN-LIN module, it's possible to inject CAN-FD messages. You can automate the whole operation with the scripting with the isystem automation APIs. A CAN-LIN module has 2 CAN and 2 LIN ports. A CAN port can be used for CAN 2.0 and CAN-FD ISO or non-ISO connections. LIN ports supports LIN 1.0 and 2.0 networks. A CAN-LIN module is used always together with the IC5700 isystem debugger. The IC5700 debugger and CAN-LIN module can be used to combine embedded program, data, and network trace if the debug and trace connections on the CPU trace capabilities are supported. The trace measurement of a program, data, and network are then displayed correlated in the same time domain. The IC5700 and CAN-LIN module is used to sniff CAN-LIN network buses. The IC5700 provides a timestamping for the CAN-LIN network measurements, and typically it also provides a timestamping for the program and data trace. A CAN-LIN module is used to inject CAN and CAN-FD messages. The injected message can be generated as a response of the network activity, or they can be generated periodically in time. You have possibility to use detected CAN-LIN frame as a trigger for trace recording message injections. You can connect up to 4 CAN-LIN modules to the IC5000 debugger when the debugger is equipped with the additional FNet hub containing additional 3 FNet ports. Now, we will concentrate on how to prepare the CAN-LIN module for the operation. The configuration is prepared and stored within winIDEA project. The winIDEA project will store a CAN-LIN module configuration, CAN-LIN network descriptions, and the isystem trace analyzer settings used for the program data and network trace. Then, profiling of the CAN-LIN networks is prepared. A winIDEA project stored all FNet connected devices, for instance, for ADIO module, Active probe, and CAN-LIN module. The FNet connection of previous connected CAN-LIN modules is automatically recognized when a CAN-LIN module is attached to the IC5000 debugger. The newly connected CAN and LIN module is also automatically detected, but a new configuration needs to be prepared. For each newly connected module, you can select alias name. When preparing configuration on specific CAN port, you could select different alias names for the specific CAN network. The CAN mode is selected among CAN, CAN-FD ISO, or CAN-FD Bosch. You could define CAN baud rate and sampling point settings. Also, CAN message injection could be enabled on that specific CAN port. Alias names could be used for the LIN ports too. For the baud rate operations, you have some options. The baud rates can be selected from the list of standard baud rates from the drop-down menu. You could enter optional baud rate manually, or you can use automatic baud rate detection on the active LIN bus traffic. The calibrate settings for the automatic baud rate detection, like maximum baud rate and the scanning time, are configurable too. Next step is enabling CAN-LIN ports for tracing and triggering. By default, the trace is disabled for the populated list of available CAN-LIN ports. You can enable tracing together with the trace qualification rules. Next step is defining of network description. Vector DBC file definitions are de facto standard for exchanging CAN network description in automotive field. The DBC format is used for CAN network description for the CAN-LIN module too. Different DBC description files can be selected for each CAN port on the CAN-LIN module. A LDF LIN description file is used for the LIN network descriptions. This file specifies LIN network publishers and subscribers, signals, and LIN frames. Also, different LDF description files can be selected for each LIN port of the CAN-LIN module. At the FNet operation window, you can also configure filtering of network message recording and prepare trigger system. The triggers could be generated at detection of specific CAN or LIN message on the network bus. A trigger could be used to inject a CAN or CANFD message. Also, FNet counters that are part of the IC5700 debugger could be used for triggering the message injections. Profiler is a real-time analysis tool, which uses the acquired trace information to drive high-level analysis of the application real-time behavior. iSystem Trace Analyzer is used for the network tracing too. You need to enable network profiling in the profiler configuration window. The profiling could combine code and data trace in the case that CPU has trace feature. Also, OS objects could be traced if the real-time debugging is configured and enabled. Let's look into Profiler Timeline window, which displays the recorded real-time CAN network activities. The recorded display presents timelines of different CAN messages. The CAN network described by the DBC description file is used for decoding rules for different recorded CAN messages. So, Profiler Timeline displays CAN messages with extracted signal values. Based on acquired trace information, the profiler statistics can determine for the network event how many times a network event occurred, how long did the network event last, the minimum, maximum, and average network event duration, the period between consecutive network event occurrences. You can get the information at what exact time the maximum duration of a certain network event occurred to. Recorded profiler data can be exported to a file on the host PC. Different formats are supported like text, XML, trace format, and MDF. You can then analyze the time properties of network and other traces with your tools offline. On previous slides, only network profiling was presented. As previously mentioned, the iSystem Trace Analyzer can combine program code trace, data access trace, and network trace. On this slide, you can see the timeline of the program and network traces. With the profiler timeline, you can also determine sequence of various events, and you can measure time between arbitrary events. The feature used for analyzing event chain time properties, propagation delay between network events, and program code is called Profiler Inspector. Profiler Inspector allows the creation of a new profiler areas in the profiler timeline. Any existing data in the profiler timeline can be used to drive inspector areas. The idea of Profiler Inspector is to create new objects whose state changes depending on the values and timing characteristics of other recorded objects. For example, we will look into an example of analyzing time properties of delays between CAN message generation and when the message was transmitted on the CAN bus. A Profiler Inspector generates a finite state machine with delay and no activity states. The delay is started at the detection of start of CAN generation program code. This information is provided with the program trace. Another event, when the transmitted CAN message is recorded with the network trace, causes transition to no activity state of the inspector finite state machine. The Profiler Inspector has generated propagation delays over the all recorded data. The propagation delay has the profiler statistics as any other profiler area. How many times a propagation delay occurred? How long did a propagation delay last? The minimum, maximum, and average propagation delay duration. The period between consecutive propagation delay occurrences. Also, the information of propagation delay can be exported. I would like to mention that this inspector example was basic. You can prepare a profiler inspector that extracts information for specific network message type, analyze extracted signals from it, and report only when the violation of specific timing or other rule occurred. isystem.connect and isystem.net interfaces allow driving isystem IC5700 debugger and CAN/LIN module. Python is mostly used, but for the isystem.connect also C++, C#, Java, MATLAB, and LabVIEW can be used. With these APIs, it is possible to control execution of embedded application, create breakpoints, perform real-time data acquisitions, run traces with profiling and coverage measurement. It is possible to configure CAN/LIN module and FNIT triggers, and much more. This slide displays an example of the isystem.connect Python script used to connect to the winIDEA session and for configuration of CAN network settings of the CAN/LIN module. Then the isystem trace analyzer is configured for the profiling. Then the embedded binary is downloaded to the target and the embedded application is executed for 2 seconds. The trace analyzers recorded the CAN network activity and the profiler results are exported to the XML file. On isystem web page is an extensive documentation of isystem.connect and isystem FNIT API. You can find documentation of classes and controllers. There are also numerous example scripts. Links are provided on this slide. So I finished my presentation and I can answer some questions. Sabrina?
Thank you, Aleš, for your demonstration. Let's continue with the Q&A session. As you already said, I think you were quite clear in transferring your knowledge, and there were only 2 questions coming in. The first one is, can the CAN/LIN module be used with the isystem IC5000 debugger?
No, CAN LIN module cannot be used with the IC5000 debugger. Only the latest IC5700 debugger that has FNIT port technology can use CAN LIN debuggers, CAN LIN modules.
The FNET is the isystem proprietary bus, right?
Yeah. Yes, it provides sufficient throughput for tracing network events and communication and automation with the external CAN LIN and ADIO modules.
Okay. And can I use the CAN LIN module if I have no trace on my microcontroller available, so with the debug connection only?
Yes, if you have the latest debugger IC5700, it's sufficient to have only debug connection to the target CPU, because then you can trace only CAN LIN buses, because you have only trace capabilities over the FNIT port to the CAN LIN module. Yeah, that's possible to use CAN LIN module, and it's also possible to trace CAN LIN traffic.
Thank you, Aleš. That were the two questions. So let's come to an end. And before you leave, I would like to give you some additional information. Next slide, please, Aleš.
Yes, okay, sure.
Thank you. So do not forget to download the presentation in the handout tab of the menu bar. Check out our free online tutorials, our YouTube channel where this webinar will be hosted, and others are already available. And if you want to, feel free to register for our newsletter to get updates automatically. If questions come to your mind later, feel free to send us an email to webinar@isystem.com. That's it from our side. Thank you for attending. Please fill in the feedback form after leaving. Take care and goodbye.
Yeah, goodbye from my side. Thanks for joining the webinar. Bye.